Let's simply start by typing in the header file. Okay, IOStream. We know that we need to use this in any C++ program. And the next thing that we know is that we need to mention that we are going to use the namespace called std, which lies within the IOStream header file. So using namespace std. Fine. Next, today we will just take a sneak peek at something new. Fine. And then immediately from the next lecture onwards, we will actually work with the different ways in which this class object relationship can be explored. How to define a class, right? So today we are going to first take a look into that. How do we define a class? We first write the keyword called class, followed by a space, followed by the name of the class that we want to define. Fine. To define a class, we first write the keyword class, followed by the class name. Now I will stick to the example that we have used all throughout our slides, which is the class called smartphone. Right? So this is the class name. If you can remember, this is almost similar to how we define any simple variable or even a structure. We write the keyword struct followed by the structure type name. Similarly, we write the keyword class followed by the class name, which is here smartphone. Okay. Next, we will start the block of the class, the scope of the class. Right? Within these braces, we will keep the class definition. That is, what are the class members? Now the classes have two members. The classes can have two members. The first one is the variables or the data members, and the second one is the functions or the methods. So as I was saying, the classes can have two types of variables, right? The first one is the data members. The second one is the member functions. So we have data members and we can also have member functions. Now, as we have already read that in object-oriented programming, the main motive is to define the class in such a way that the data members of a class are only accessible to the member functions of that class itself, isn't it? So we will see how to enforce that. Fine. So let's say my class smartphones has a data member, a single data member right now. There can be n number of data members, but we are just beginning today. So we'll just take one simple data member, int RAM. Fine. So RAM is nothing but a variable value, right? Which is a data member of the class called smartphone. So every smartphone has a particular RAM, isn't it? Fine. So we are simply trying to model the real life object to a template in object-oriented program. Fine. So I have the data member called RAM. Moving on, I need to have some member function. Now here comes a question. Sir, I have only one variable. So what will this member function do? Right? So I can simply, in this case, use a member function that will print the specification of my object of class smartphone. Again, I can simply have a member function which will access this int RAM variable and which will print its value, which will tell the user that this smartphone has this GB of RAM. Fine. So for that, I can simply define a function. The function could be like this: void print underscore SPC. SPC is for specification. You can name it anything else. Fine. And since it's a function, open and closing brackets followed by a semicolon. Right? So this is the class definition. What have I done in the class definition? In the class definition, I have first said that I will have a data member which goes by the name RAM. So which will actually indicate how much RAM my smartphone has, my particular smartphone object has. So as I was saying, my class smartphone, I'm defining a class smartphone this way, right? So my class smartphone has a data member, a set of data members it can have, and it can have a set of member functions. Now in this case, I am keeping things simple because this is our first step into actual object-oriented programming, right? So I am just keeping a single data member, int RAM. So this will obviously store the RAM size of a particular smartphone model. Good. Next, I am keeping member functions only one right now. So I could have a function called print_spec, which is simply about printing the specification of the smartphone that is being used, right? Next, another thing about class definition is that the class definition has to be ended with a semicolon. Just like you did with structures, here also you will end a class definition with the semicolon. Fine. Now, please note that whenever I am creating, if I simply save and execute this program, will there be any memory space occupied? No, sir. No memory space will be occupied. A simple template will be just defined. That's all. This we have already learned, right? But what do we need to do now? We actually need to create an object of this class type. We have to have an object of class smartphone. So we will come to that in a little while, right? Before that, there is another crucial concept that we need to learn today. That is the concept of access specifiers. We need to learn the concept of access specifiers. Now, there are three types of access specifiers in C++. Please make sure that you try and understand what I'm saying. This is a very simple concept. There are essentially three types of access specifiers. What are they? The first one is public, then we have private, and last of all, we have something called protected, right? So we have public access specifier, we have private access specifier, and we have protected access specifier. Obviously, the name access specifiers is self-explanatory. It means it specifies what type of an access a class member can have, right? An access specifier helps us to specify during the class definition about what type of access a class member can have, right? Now, the default access specifier is private. Please note this. The default access specifier is always private. So whenever I am defining actually a class member, which could be a data member, int RAM. So by default, is access specifier is private. So by default, it is kept as private. Private by default. And that is what we want from object-oriented programming, right? We want that our data member is kept private. That is, it is not accessible outside the class, right? This data member, since it is private by default, it is not accessible outside the class. It is only accessible via members within the class. Okay. Are you clear with this? Whenever we have a data member, they are kept private by default. We can change that. How do we define this access specifier? We can simply write something like this, private colon. Right? We can simply write private colon. Now that essentially means that whatever data members I am defining, just keep them private. But by default, even if we don't write this, the default access specifier is always kept as private. Because that is what object-oriented programming wants from us, wants us to do. Or that is what we want from object-oriented programming, the security of the data. Am I clear? Yeah, Deboru, by private, what does it mean? Again, as I said, by private, it means that my data member is not accessible outside the class. By private, it means that this RAM variable of integer type is not accessible by anything outside the class. Fine? And we will come to check, we will come to see how that works, right? We will come to see how that works very soon.
Sir, if now, I want to make this variable as public,
we are coming to that. Ayush, we are coming to that. Let us first go up till defining an object of the class, okay? And then we will keep changing this access specifier and see what can be done. Fine. So do not worry about it. We will explore all the possibilities, okay? Just take some time. Fine. Now, another thing is that I have this member function called print spec. Fine. But this member function, see, I have not defined this function, isn't it? So I need to define this function. So in order to define this function, let's say this function will actually contain few things. It will contain a cout statement. It will say the RAM of this model is, excuse me, is, then I'll print the value of RAM, right? I'll print the value of this variable, and then again within quotes I'll write GB. So the statement will be something like the RAM of this model is 4 GB, or the RAM of this model is 5 GB, and so on. Fine. Okay. So this is what print spec will do for us, right? But it's a very simple thing that I have this variable called RAM, and I'm trying to print its value, but I have not even set a value for it, right? So whenever I'm creating an object of this class, the object will obviously have a variable called RAM, but that has no initial value. Now I can initialize to 0. I can initialize it to 0. That is not an issue. But even in that case, it will always say the RAM of this model is 0 GB. So that is not an ideal situation, right? So that is why essentially we have two types of member functions. One is called a getter member function, which gets the input from the user. So we will have something like void get specification. Now this function is tasked with getting the input from the user, right? So we have something called void get spec, and get spec will actually ask the user first, say enter RAM, right? And it will take that and save it in the variable called RAM. Now again, let us go through what we have done. We have kept a member function called get specification. Fine. We have kept a member function called get specification, and which is asking the user to enter the RAM and storing that value in the variable called RAM. Fine. And then there is a function called print specification, which is actually giving an output to the user. Fine. So this is a function for accessing the data member. These are both functions for accessing the data member, which in this case is private, which means this data member is not directly accessible outside the class. It's accessible only via the functions, the member functions of that particular class. Once we have come to this, there is another essential concept that we need to know, right? Default access specifier of member functions has to be public. Public because these member functions need to be accessible from outside of this class definition. If I may reduce the size of this whole thing, then you can see that the default access specifier of the function is set to be public. So I should write something like public colon. Again, note that int RAM, I have not defined any access specifier, so it is kept at private. The functions are both kept as public. Why? Because these functions need to be accessed from outside of this class definition block, isn't it? So how do we do that, sir? So let's check it out. So now we have defined the class definition. I have a private data member. I have two public function definitions. Now we will write a main function. We will write something like this, int main. Fine. And within int main, what we will do? We will create object. We will create an object of class type smartphone, which we had seen in our initial slides. Right. So what do we write? We write the class name smartphone, followed by the object name, which is Poco F1. right? So this was also a question in your previous quiz, and this has also been shown in your slides. How do we define a smartphone? How do we define an object? We write the class name followed by the object name. Fine. Now, what do we do? Once we have created this object, please mind that Poco F1 here is the object. It's a particular model of smartphone. It's a particular implementation of the class of smartphones. Now, using this Poco F1 object, we will simply call, or we will simply use the getSpec function of this particular object called Poco F1. Again, getSpec and printSpec, these are defined in the template of class smartphone. So whatever implementation of class smartphone I have, they will all contain the functions called getSpec and printSpec. This we already know, right? So here I am trying to call, here I am trying to use the function getSpec of class Poco F1. First I will do that. Once I have done it, my class Poco F1 will have a particular RAM value that is defined. Fine. The next thing I will do is I will try to print this specification. I will again write Poco F1 dot print underscore spec. Fine. So here what I am doing, I am simply trying to print the specification. So see, getSpec was supposed to take the RAM as input, and printSpec was supposed to print the RAM as output. Now, one thing again should be clear from this. See, these getSpec and printSpec are being accessed using the dot operator, isn't it? So this is another question that you should have. Sir, why the dot operator is being written? Because that is how we are accessing the member of the class. That is how we can access the member function of the class. Okay. So this is similar to how we used to access the structure members. Back in C programming, this is how we used to access the structure type members. So once we have done this, we have actually called the two public functions of the class. Now these functions are kept public. Why? See, because this is where my class definition ends. Right, this is where my class definition ends. And the functions getSpec and printSpec, they are defined within this class definition itself. So if I do not keep them public, I cannot expect to access them from within the main function also. The main function is completely outside of the class block. So I have to keep my member functions public in order to be able to work with the object. Right? If I want to be able to work with the object, if I want to be able to work with the data members of the object, I need to keep my member functions public. Right? Okay. So once I'm done with this, I can simply try and write something like a return 0. Fine. And I'll close this main function block and I will save this. Okay. Once I'm done, let us go to the terminal window. I hope the terminal window is visible to all of you. So here in the terminal window, we will write G++, our file name. And see, my code is compiled without any errors, right? So if I'm supposed to execute my code now, I'll write /a.out. And it will ask me to enter the RAM, right? So just announce a RAM value for me. Someone of you.
4.
Okay, 4. Good. So it is simply printing the RAM of this model is 4 GB. This is what I wanted it to do, isn't it? This is what I wanted it to do. So again, if we come back to the code, what is actually happening? Now, first we are creating an object of smartphone class called Poco F1. This particular object will have memory representation. It will have impact on the memory, right? So then what I am doing, I am simply using the get specification member of the object called Poco F1. This get specification member, whenever it is being called, it will ask the user to enter the RAM value, and that somebody said was 4. So I put that as input. After that, what happened? After that, again, I had called the print specification object, isn't it? Once I call the print specification object, it was supposed to print that the RAM of the model is 4 GB, and that is what it did, right? So this is a very simple example of how you can work with object-oriented programming concepts. How you define a class that we have seen today, how you define objects of the class that we have seen, and how to access the members of the class using the dot operator that we have also seen. Now let's come to a few interesting things. The question that all of you, I hope, initially had, that, sir, what is the role of private? What is the role of public? Now tell me, what is the private member that I have? I have the private member called RAM, isn't it? Which is private by default. I have not changed this access specifier value anyhow. So it is private. So let us simply try to access the private member of Poco F1 called RAM. I can do that. I can simply write Poco F1.ram, semicolon, right? And let us save this code. I hope you understand what I'm trying to do. I'm trying to access the private member of my class smartphone's object Poco F1. This RAM will be a private member, right? But I'm trying to access it directly from outside of the class definition. The class definition is over. I'm trying to access that private member from within the main function, which is outside the class definition. Let us save this code and let us compile it again. See, I will get a problem. It will tell me that int smartphone, that is from the class smartphone, the integer value, which is called RAM, that is private within this context, right? It will not allow access to me. It will tell me that this variable is private within this context. You cannot use it right now. It was declared private where? This was declared private here, int RAM. Fine. So I hope this answers your question. What is the meaning of private? The meaning of private is that I cannot actually use that class member. It could be a member variable. It could be a member function. Private usually means that I cannot access that member variable or function from outside the class definition. Not even if I create an object. I am creating the object in main function, right? This is what a doubt many people have. That, sir, I am creating the object within the main function. So the data members of the object should be available within the main function, but no, sir, that will not happen. Because the object is nothing but of the class definition. And the class definition strictly says that this data member, which is RAM, is a private data member. So that is not accessible anyhow. That is not accessible anyhow, not accessible anywhere. Now let us do something that we should never do, that we will never do. But just for the sake of understanding, we are again trying this out also. What are we doing, sir? We are writing public before our data member. Now this is something that you must never do, right? Never do this. Let us type it in all caps. Never do this. But I am just showing this for the sake of your understanding. Let's suppose I have kept my data variable, right? Which is int RAM. I've kept it as public. So what will happen, sir? Now I will not get any error when I'm executing my code. On compiling it, I will get successfully compiled. On executing it, I'll enter a RAM value. And I will get the RAM of this model is 6 GB. Fine. So in this case, this Poco F1.ram, that is being accessed, but I have not printed it anyhow. So how do I print out, sir? I will print it out by writing cout. So I will simply print out the value of Poco F1.ram. So now I am supposed to get another 6 written after everything, after every operation is done. So let's check that out again. It's compiled successfully. On executing it, I'm getting this sort of output. The RAM of this model is 4 GB. This was the output of the print spec function, followed by another 4. This is the output that I get because of writing this Poco F1.ram. Fine. So what has happened now, sir? What has happened now is that my data variable, my member variable, which is the most important thing to me in object-oriented programming, I have purposefully set that to public. So that is now accessible to anybody and anything outside of the class definition. That is not a desirable scenario, but I have purposefully done that in order to explain what happens, right? So see, my RAM variable is now accessible to anybody and anything. Anybody can do anything with it. So I don't want that. So in all cases, for all practical purposes, we will always try to keep our data members as private. We will always try to keep our data members as private. And for that, you do not have to do anything. Just do not define an access specifier explicitly. By default, it is always private. Am I clear? So this is a very simple example again of how we can actually create a class definition, how to define a class, how to create an object of the class. Now, can I create any more objects? Yes, I can create n number of objects. I can have another object called 1 plus 8. That is also feasible. That is also possible. Not an issue. Okay, that is also possible. I can create another object called 1 plus 8. I can have another object. I can have another object called say Redmi 9. I can keep doing this. And each of these objects has their individual getSpec and printSpec functions. Just like I have these functions for Poco F1, I will have the same data members, that is int RAM, and the same member functions for all. Right? So you need to keep this in mind. So I can have 1 plus 8 getSpec, which is separate from the getSpec of Poco F1. Similarly, Redmi 9 will also have a getSpec and printSpec and RAM variable, which is different from that of all the other objects. So this is how I can work with different objects. Let us again compile and check. It is fine. Let us execute it. So enter RAM. So the first time I'm entering the RAM, that is for Poco F1. So I've entered 6. The RAM of this model is 6 GB. Again, it is asking for another enter RAM. Let it be 7. RAM of this model is 7 GB. Another RAM, 8. RAM of this model is 8 GB. Please note that this 6 GB was the getSpec and printSpec for Poco F1. This 7 GB was the getSpec and printSpec for 1 plus 8. This 8 GB was the getSpec and printSpec for Redmi 9. And all of these have used their own copy of the variable which is called int RAM. And this RAM variable is, because of our understanding now, not at all public. It is not directly accessible. It is private. So what we had studied in our slides, that the data member of a class, the data member of an object actually is only accessible by the member functions of that object. So getSpec and printSpec are the member functions of this particular object, and the data member of that object, which is int RAM, is only accessible via that, because I have kept it private, and that is what is wanted from us. That is what people want us to do. Right. So I hope you do not have any other pertaining questions with this class and object use or the class and object definition. If you have, then please ask away. Okay, why did I use semicolon? Good question. Sumantro, just like we define a structure, right? Whenever I'm defining a structure, just as I use a closing a semicolon after the closing bracket, similarly for the class we have to do that. That is the actual syntax that is followed for the user defined types. See, this class, structure, all of these things are called UDTs, right? They are called user defined types. This we have seen in the previous session. So all of these user defined type definitions always are supposed to end with a semicolon after the closing bracket. So that is how the compiler understands that this is a user defined type, right? So for the primitive types, say integer, float, we are not getting to define them, right? But for the user defined types, we are getting to give the definition out. In order to be actually processed as a proper definition, all the UTTs have to be closed, or the definition of the UTTs have to be kept closed by a semicolon.